Hello, I'm Darren with Sensenich Propeller, and today we're going to do another installation video for you. In the previous videos, you've seen where we've put together a 3-blade JR series and installed it up onto the engine here with some tips on tracking. Today we're going to go over putting together one of our multi-bladed systems. This is our Talon series. It's one of the newest ones that we've had out as of late. We're going to go over all of the tools that you need. There's not a whole lot of stuff required to put these together. There is some things you need as far as setting pitch that is unique to these. Just like the Sabres, the Vortex, and the Alphas, you need some kind of angle device to measure it. In previous videos, you've seen us talk about tracking, which is really good for 2 blades, 3 blades, wider blades that require a more finessed, true running of the blades versus the plate system with multiple blades where angle is a bit more important than track. We don't even really talk about track too much once you get into a 5, a 6, 7 blade and up. We're more worried on getting your angles set correctly. We'll go over how you install this on an engine in the installation instructions that you get from us. It will talk more about putting it together off the boat, but when you get into the bigger diameter props, the 7, the 8 blades, the 10 blades that we're doing a lot these days, it's a bit more difficult to get those in without taking rudders off of the boat and that kind of stuff. So we're going to do a quick assembly of how you put this together and just kind of the way that we like to see them on the engine, and how to final torque, pitch set, all that good stuff. And at first, what we're going to talk about is the parts that come with each prop. Now, you'll have a variety of bolts, washers, nuts, plates, blades, all that good stuff. And depending on what you purchase, there will be a different quantity of some things that you see here. So don't let that worry you too much. As long as you go through and lay things out and double check what you have before you start your assembly, you shouldn't have any issues. We always recommend that to anybody that gets one of these. Kind of lay out all the parts, lay out all your washers, make sure you have everything you need before you start putting it together, because the last thing you want to do is be halfway into an install and realize that you're missing something. We try to do our best to ensure that everything that we ship out of here has all the necessary hardware, instructions, and whatnot, but mistakes can be made. We just try to keep it to a minimum. First thing we're going to talk about here is we have our plates. Every prop will come with a set of plates. Now, depending on what you purchase, we do offer this in what we call a standard setup, which is just a 2-plate system. We do a stacked option, which is a 3-plate system. That's where you have additional spacers, an extra plate, and it's something more racers like to use. They seem to think it has a bit better top end potential and that kind of stuff, and we've seen that in testing results over the years. But for the most part, if you're buying one of our standard, what we would call off-the-shelf products, you're going to get the 2 plates. You're going to get all the necessary hardware that comes along with it. You're going to get your pitch blocks, spacers that go between the plates, and your blades. You can order things from us like digital angle finders. A lot of people like to use these. You can typically buy them right off Amazon. They're somewhere around 40 to 50 bucks, depending on which one you're looking at. The key thing is you do want to get one that registers to 2 decimal points past, so you can get within, say, 1/4 of a degree. We like to try to get these things within 1/4, just because if you get outside of that, you can start to feel some vibrations. You're not getting as efficient performance as you would like. And the 2 decimal place on something like this will definitely help to keep you in that range. There are a wide variety of different protractors and whatnot you can get. A lot of people still use the old warp drive protractors. I did not find one of those this morning. I think we've stopped using them. We used them for quite a while. But the digitals seem to work a lot better. They're more repeatable and kind of easier to just keep around. I'm gonna have a magnetic base. You can stick it to something if you need to. So now we're gonna go through putting this thing together. We're gonna start by assembling some of the parts on the hub, and then we'll get it up onto the engine here in the gearbox, and we'll start in putting blades and go through the torque sequence and all that good stuff of how we pitch and go from there. Thanks. Okay, we've moved some things around here. We're getting ready to put this thing together. One thing I did leave out is a lot of people ask, how do I figure out what I have for a prop? If you bought a boat and you don't know what's on there, a lot of times you can simply take a tape measure and do some measurements from, say, the center of the bore out to the edge of the plate. And you can give us that information. You can measure your blades. There are standard links for stuff that's on the website. If you go to the installation instructions, it'll tell you that kind of stuff and information. There's even some of that stuff that's on the website, period, before you even have to get into the installation instructions. But you can measure plates, you can measure blades. The way that we reference blade measurement is we always measure the blade from one end all the way to the other. The talons here, you'll see that are 35 inches long. They are 2 inches longer than what you would say a standard saber or a vortex is. This blade was designed for mostly racing. It is one of our products that does not come with a warranty, just because that's the way we intended it to be used, was on boats that are going to push the ultimate limit of everything they can do to get the most amount of power and speed out of their boat. So we've made these extremely lightweight so that they're very responsive. The idea with making the blade longer is so that we could reduce the overall size of the hub system. The old warp drives and sabers, when you try to get into diameters around 80 inch, 82 inch, the plate sizing grew to such a big overall side and footprint that it would almost match the size of the engine, which for some people thought was a really good thing, and it was for the time and period of when that stuff was made. But we found that making the blade a little longer, we can reduce hub sizing. We can move what we call our center of rotation, or center COR, inward extremely, and move some of that weight with all the blocks and the bolts in to try to help reduce inertia. These boats that make extreme power, they want to torque roll extremely bad under high power input. So we're trying to reduce that as much by bringing the center of mass inward. And it's worked very well. We released the Talon, probably 6 years ago now, and it took a while for it to kind of grab on, but almost every high performance boat you see these days is going to have this prop on it. The other thing you can do with your plates is we do have markings on these. Not to your traditional stuff where you see things on the face. What we do with these is we are putting the information on the flats on the ends of the plates. We will have where you have a serial number on one side of the plate, and then we actually put the model number on another side. And you can reference this to us to let you know, to figure out what you have. With the Saber and the Talon, we do intermix these a little bit. We do stamp some things with a TAL for Talon. Some things are stamped SAB for Saber. You don't have to really worry about that too much, because we will kind of intermix those depending on what the customer wants for diameter and overall sizing. If you think about our typical Saber installations, if you had a 540 aircraft engine that had a 6-blade 72-inch Saber on it, you can simply put Talons in that hub assembly and now have a 76-inch diameter prop. That's how much difference the blade length makes. Gives you a little bit of an idea. So first, what we're going to do, as you get with every kit, you will get anti-seize. We do recommend using this on everything, even your bolts that have the lock washers with them. We recommend putting just a small dab inward of the threads to help with that initial torque load. We don't recommend you running the anti-seize all the way out to the end of the threads, because that's where you kind of want the nylon engagement to work. And even though it doesn't really impede on how that washer and nut assembly works, we still recommend that you use this. I like to take, if I'm going to put a prop on a boat, simply put the washers onto a few bolts to get started. So to initially start, I just get a couple of bolts loaded into the cap or the cover piece. I put a couple of spacers over where I know this is going to line up, and then I just simply drop this into those spacers to kind of get me a good rough start. This way I can now take the assembly together with the bolts through, and I can go up onto the engine with it. Now once I have the bolts started and whatnot. The big thing is you do want to double check that you do have the larger counterbore side ready to face towards the gearbox or the engine. That's key to make sure you can get this up on here. And then like previous, I'm just looking through some of these holes to initially get this lined up and get it onto the engine. And then once I have everything kind of lined up, then I'm gonna just hand start these bolts just to kind of get it up into here. And then from that point, I will put in the rest of the spacers and the bolts one by one. Now you could go and load all of your bolts and washers and put all your spacers on and everything like that initially, if that's how you would like to do it. I'm just making sure none of this is falling out and I can lift this plate, simply slide this in, line it up over the counterbore, and then just start some threads. Remember, this would all have anti-seize on it. If we were doing this for a permanent installation, anti-seize does help for getting the correct torque on the bolts, as well as giving you a layer of lubricant to help protect from corrosion, that kind of stuff. All you really need is a 3/4 inch drive. You need a torque wrench, a 1/2 inch open end wrench, and a 1/2 inch socket. I did have this on the table. The only reason you need this, or you would want to use this, is just to get initial start of everything down to where you can get close to pitch setting before you do any final torques. This is definitely not what you want to use to set your final torque on the blades. We recommend 18 to 20 foot-pounds on our smaller 5/16 bolts. This, I believe, if you do the research on this will even torque higher than that if you were to utilize it to try to do final torque. The blades and all this stuff is very sensitive to torque. We found that over torquing the small bolts that go around the ends of the blades that are in this location here can cause more damage than you would ever imagine. We actually believe that 18 is really where we would call more of a max setting, or that's what I tell a lot of people. I tell them, don't really go over 18 foot-pounds at that high. It's putting extreme amount of grip strength on the shank. Plenty enough for taking any amount of power you want to put to the prop with no issues. What I'm going to do is I'm just going to kind of snug these up a little bit more. And I'm not even snugging these up yet. I'm just kind of getting some more thread engagement here to just ensure nothing's going to come off, flop around. And then I will use this to just ever so slightly seat the plate. So I will kind of come in here and just do a couple of clicks just to make sure everything's down. This is the point where I'm going to make sure that my spacers are all aligned perfectly. I have no spacing between the plates itself and the drive. The flange in the output shaft, where it's a gearbox belt drive, direct drive, it doesn't matter, aircraft engine. Another key thing is always making sure that this hub is flush against your drive flange. Remember, the torque on the bolts is just to create a drive friction between the face of your hub assembly and the flange of whatever's trying to drive it. That's if there was no drive assembly there and it was just bolts, you just shear stuff off in a heartbeat. And if you're sitting off of that flange, you're gonna shear bolts. So just doing this as a quick pre-check to make sure everything's nice and down. Then I'm gonna back this out of here again. The idea is you don't want it to be too tight because you still have to get the blades in. Like I said, this is an assembly on the boat per se, not on a bench. If you were bench assembling this, everything would still be pretty loose at this point. You would be loading blocks and blades and putting all the bolts in like the instructions say. This just is some way that most people prefer. So now we're going to start the assembly. we've kind of laid out all of our bolts over here. We've put all of our washers. The keynote is we do send enough washers and nuts so that you get full, like you would get 1 bolt, 2 washers, and 1 nut per each hole that you're going to send a 5/16 bolt through. So part of your pre-assembly and check and that kind of stuff, just verify you have all your washers, your nuts. Some guys, when they're really trying to get everything they can out of these things, they will leave 1 washer off. We have guys that have removed the washer on the head side of the bolt. Even though it's not recommended, we haven't seen where it really causes too much of any issues. They'll just run 1 washer on the nut side for torquing. But we do like to put all the washers on. We think it helps with just giving you a nice even torque. It helps with assembling this thing correctly. Now initially, you don't really have to worry about the nuts when you're first starting to put things together. I just kind of like to get a set of the blocks. You will notice that one side has a chamfered edge to it. This is to mate up to the chamfered edge on the back side of the shank. We have, believe it or not, had people try to put them on this way. The other key thing is if you did mess up and put them on backwards, the way that these plates are designed and drilled, you would not be able to get the blade in and get the bolts in. There's kind of some redundancy there. So what I like to do is I just kind of like to get a block on the blade where it's got a hold of it. The back side, our decals typically always face forward on the boat. There is some, we do get that question a bit. We just found that on the back side of the blade, decals like to just come off under use, so we don't worry about that. But so we're gonna bring this up in here. The plates are spread apart. We do have our bolt ready to go in, and we're just going to get this into the first hole location, and from there it will stay in place. From that point, we can just roll the blade around and get in another bolt. Now, you can put these in either direction. And the reason why I'm saying that now is because I'm catching myself. I do a lot more aircraft installations. That's just more popular where we are here in Florida, in the area that we run. On the automotive side, you can run the bolts through on this side because you can still get a torque wrench on the back side to get to this bolt. In the aviation market, you have to do it this way, or at least a lot of people believe you do, because in the smaller compact hub, if you were to put the bolt in the other through the mount half into the cover to get to the nut, you run into issues with the flywheels that are on like Lycomings and Continentals, where if you do have a blade that's damaged or something, you just want to get that out and replace it. You cannot get the bolt out and pass the flywheel. You would have to take all your bolts out and get it off to get that out. So a lot of the aircraft guys like to put their bolts in this direction. If you want to be able to torque from the outside and make it a little easier on yourself so you don't have to get back here with a torque wrench and work on things, you can bring the bolt through the backside where you can actually torque the nut from the back of the boat where it's more accessible. Either way, it's completely up to you as the end user. Like I said, it's not something critical. Like right now, I'm trying to get a bolt through the backside here, and it's actually hitting the gearbox. So I could turn this to get it into a better location, to get it onto the, I could get it up here out of the way to get the bolt in. But for simple purpose of just getting this video shot, we are going to not worry about that too much. We're just gonna get the bolts in. The key thing when you're putting this all together is this blade can move up and down in here, especially while you're doing an assembly. So one of the key things you want to do is always make sure that before you do any final torques, before you do any pitching, you want to get this blade fully retained into the pitch block before you start doing any pitching. From this point, we would put some washers on and put some nuts on the back side of this to initially start to just keep these safe where these won't fall out as we kind of go around. But what we'll do now is we'll go through, we'll put the rest of the blades in. You can keep the prop sitting anywhere that you would like, as far as you don't have to rotate it to get a blade in or anything like that. You can simply just start loading the blades as is, and then we'll come back and we'll show you how we do our final pitch setting and torquing and go from there. Thanks. Okay, as you can see now, we've put this thing together. Everything's still really loose. The blades are free to kind of move. All we've done is hand started the nuts on the back of the bolts. All the blades are in. Some of these aren't fully seated like I was speaking about earlier. At this point, everything is snug enough where I can then come back to the main 6 bolts, and I will just use this to just bring enough of these in to where it is now closed up. None of this is torqued, but it's at least tight enough that now nothing up here is going to move around. And that's going to allow me to kind of move some things around and start some pre-torques and some pre-checks. Initially, what I try to do is just eyeball putting some angle into these blades. A lot of times when you first put them in, they're going to be a little bit just out of whack. So I just roll some pitch to them to get the way that I want it to look. And then I'm going to bring each blade down into the boat, and I'm going to make sure it's fully seated here. And then one of the tricks that I like to do before I do any final torques, and I'm just getting these ready, is I will use this just to snug the bolts. I use my finger on the back side of the open end wrench so that I can feel the threads come past the nylon nut. Initially, if you just get the bolt flush with the top of the head of the nut, you can still move the blade around enough and try to pitch it and whatnot before you go to final torque. You want to start with one of your bolts, just to kind of, like I said, you're just getting the bolt snug, and then I'll jump to the adjacent bolt across just to get that snug. Then I'll come to the other bolt on the back, just get it snug. Just to get it snug. And now you can see that the blade is still loose, it's still free to move. So I'm going to bring a little bit more of these down. Initially, you want to just be pretty careful on how you bring these down. You don't want to put a whole lot of load on the system. And now you can see that it will still turn, but now it won't freely move around. And that's kind of how you want it. I will then bring another blade around. And when pitching a prop and putting one on, you always want to make sure that if you're on an aircraft engine, your mags are off. A lot of people will tell you to disconnect the battery. With the engine switch here, we don't even have the ECU. This is kind of a standalone ECU system. So what actually controls the computer on the engine is on a stand. It's unhooked, the battery's off. We're definitely safe on our end here. Okay, we went through and we just snugged up all the bolts. Now, remember we've actually put some decent torque to this. I'd say these right now are probably torqued to about 30 foot-pounds. About half of what we recommend on the mount bolts, we recommend 60 foot-pounds. We did talk about torque on the smaller bolts, but these are just snug. The blades can still twist and turn. I have made sure that each one of these blades are fully seated into the pitch block. And now we're going to go through how we set up and get ready to start measuring blade angles. The key is to make sure that each blade is measured in the same spot. You can reference that in 2 different ways. Some guys will use their digital level where they'll put it, if you can see this, they'll put it sometimes up here where they'll actually get a degree measurement at the leading edge. Some guys will also simply take the tape measure and they'll run the tape down to the bottom of the boat or something down on the boat, and they'll get a measurement here so that when they bring each blade around, they're coming to the same location. But the key is that you want to make sure the blade is in the same location as far as going horizontal. That way you're getting the same angle check at the same location. You don't want to try to go back and forth like if you had multiple blades where you're going from this side to that side. You can get some stuff with the boat being tilted one way or the other, and the blade will be in a different plane. So I try to tell everybody, even though it's a pain, try to check every blade one at a time in the same location. Now, as before, what I tend to do is pull out a tape measure. Where we're going to check blade angle always references, and it's in your installation instructions, from the edge of the plate out to the end of the tip. And on the talons, even if they're cut down full length, it doesn't matter. We're telling people to go to 29 inches. And what I'm doing is I'm just measuring, I'm just putting a little mark with a pencil right on the leading edge. And that will allow you to then have a reference. Now, when you if you do decide to use a digital tack, it's always best to come to the center of the plates here where it's nice and flat and zero out your level. You want to make sure that it's giving you a nice accurate reading, because what you don't want to happen is for this thing to be off and you think you've set it to a certain and this one's being a bit finicky, but you want to make sure it's zeroed. And that way, when you start to set your blade angles, you get an actual idea of what the pitch is. A lot of customers, when they call us and they're telling us, well, I think I've got my blades pitched here, they haven't taken the time to try to either level this out. You can level it by referencing it this way. You could simply put a level, like a regular framing level on here, and use a bubble if you want. But it just needs to make sure that whatever this angle that you're giving us is referenced to this being perfectly level. The way that you're holding this on here when you're zeroing out is definitely the same way you want to hold it once you come out here. And all you'll do is simply reference this to the mark. I like to leave it where I can see it. I like to bring the level up to the very corner of the blade here. And I'm just holding this as close to eye as what I can visually see. And right now it's telling me I'm around 14 degrees. On most of these multiple blade high performance Talon combinations, I tell most guys you want to start roughly close to 12 or 14, depending on whether you think you're highly loading the blades or not highly. When I say that, blades per horsepower. This being a 5.3 LS, it's probably in the mid 400 horsepower range. We're doing a 5 blade today. I'm not going to highly load this. This is a low horsepower. It's, if it was a 500 horse engine with 5 blades, that's 100 horsepower per blade. I'm going to tell you that you want to start in the 14 to 15 degree range. If you drop below 100 horsepower per blade, I would tell you to start somewhere in the 12 degree range. Right now we're at 14. We're a little bit on the light side of that, so I'm going to probably just take this mallet, and again, just like with the other blades, we do put solid material back in here. So you don't want to do a lot of pitch changing up here. You can, it's just not as nice because this has a bit more of a sweep to it. So you can come back and you just lightly want to tap on this. You will find that as you make small changes to this, it'll make a big change out at the tip. And it's just slightly tapping it. If you have to hit it much harder than that, you've gotten everything way too tight before you start. Now I would call that 12.5, and I would probably leave that here to start. Once I have that blade pitched, I grab just the tools that I had previous to snug all this up, and then all I'm going to do is I'm just going to hit these enough that I'm gonna lock this down where it just doesn't really want to go anywhere at this point. I can kind of hear it make a little bit of a ding, and then you can see that there's actually now threads passing the nut head. So I've now taken it from being more of a flushed feel to having threads coming through the nylon section of that. And at that point, this will not move. This is now sturdy. It's tight, it's not gonna turn. The thing that you don't wanna do is you don't wanna use this blade now to go and pull and bring it around to set, because you never know, you could yank on that thing and turn it. I like to just go to the next blade. I will take a reference of where I have this blade to just the floor since we're here in the shop. And I'm right at 67.5. And we'll just do this one more time. I'm gonna turn the prop backwards at this point. The reason that I like to do one blade at a time is because I'm gonna mark that tip location for where I'm gonna check the blade angle. If you're doing a 10 blade or an 8 blade or something like that, you'll get, unless you put something on here or write the number of blade or something, you'll find that you're not sure if you've set them all or had them all pitched. So being that I've got this one tip marked now, I know that I've set that one. And at this point, I would just rinse and repeat. I would get this blade tip set to 67.5. With the gearbox, it makes it a little bit finicky, but now I've got that set, and then I can measure out to the tip again. And again, I'm just gonna set this at 29. Gonna make my mark right on the metal edge again so I can reference it. I can already tell that this thing has a lot more pitch. I can visually tell it's got a lot more pitch. I bet it's up around like 30. Yeah, 28. So this would require a lot of angle adjustment. Now this blade is turning pretty easy. So I will set this, and I'll tell you one other last tip that I would recommend, that if you're pitching one of these. Now we're back to 14. .55. That's within what we would call a quarter. When we talk about a quarter of a degree, we're talking, you know, if this is like 12.5, if you went to 12.75, that would be your quarter. So you're utilizing this to, like I said, give you that angle check. And the digital angle finders can be very finicky. So you want to just be steady, let it settle out. Once you check it, one other thing I would recommend, that if you got one that turns really easy, I would start to bring these bolts up. And like I said, I am kind of torquing these in a method of, I'm going across this way, then down, and then back across. To me, that's the best way to try to bring it down evenly. What you're trying to do, oh, that was way too much. What I'm trying to do, like I said, is just get some threads past here, make sure this is now fully tight. But what you're also trying to do is you're trying to maintain a pretty good even gap on the pitch block. We've had some people that put these together and they just start bringing the bolts down, and they'll have side loaded bolts here, and then you don't really get good even torque. You end up kind of warping the plates weird. It just makes things a little interesting. But if you get one that's really easy to pitch and you do get it set, the one thing I would recommend to do is, before you move the prop or go anywhere with it, you could come out and just double check that the blade hasn't moved. Or if it has, you can then take the time to reset it. This is what we would call within 0.05 or 0.1. Didn't really move that much, so that's good to go. Now you would go through the entire sequence like this, getting all the blades set. And at that point, once all the blades are set, I would recommend to get your torque wrench out. You would initially set this to 60 foot-pounds. You would put your 3/4 inch socket on, and you would come in here and I would torque all of your mount bolts. Go ahead and torque those down. That way everything is perfectly torqued here. That's step one, you know that's done. Then you can change over to your 1/2 inch socket. And at that point you would bring this down. I would tell you to bring it down to 18 foot-pounds. And you would then go one by one on each blade. And you could either get on a side where you can access the nuts. That's your best way to torque it. But just like before, you would then want to come in, get a hold of the bolt head, and you would want to, you don't want to go to full torque. You would want to give it a couple of turns on each bolt, jumping around, working your way up so that you're bringing down the torque evenly, and then jump down again. Now this isn't going to allow me to get on here. But you would then jump across each one and just kind of work that torque down to where you get to the one. Like I typically try to do maybe 1 and 2 turns and just keep going from each bolt until you get to the first one torques. And then at that point, you can just go to full torque, which will be 18. Once you've done that on each blade, you can either choose to go back and recheck your angles. I probably wouldn't do that. I'd get all the tools off the boat, clear everything, make sure everything is nice and tight, do your pre-checks, and then I would fire it up, get the engine warmed up, and see what you get for full RPM. These are intended for racing applications, which means they do carry a higher RPM rating, just like the Vortex and some other props. This prop, I believe, has a 2650 RPM rating at like 82-inch diameter. At 78, guys are turning this prop upwards of 28 to 2900 RPM. And on an automotive engine through a 268, that's engine RPMs into the 7400 RPM range. So that's what these things are intended for. This is, if you're kind of comparing this from a 3-blade to what we're showing you today, this is all about speed, smoothness, and great cruise efficiency. This is the predecessor to the Sabre. The Sabre was introduced in 2004, and that was great on a lot of sleds, aircraft engine hunt boats, and it was really fast. It wasn't even intended to be fast, but it just so happened that in 2004, we were just tapping into the potential of composite blades, and the Sabre hit it right out the mark. When we introduced the Vortex, that was the second version of what we would call our Sabre for aircraft installations for mostly racing purposes. And that did very, very well in sanctioned racing as well as on boats that hit the lake. This was no different. We introduced this thinking that we were going to have some sanctioned racing coming in about 4 or 5 years ago. It just didn't happen. And we've got guys that have purpose-built what we call test and tune boats. And they have gotten a hold of these, and versus our Sabre, we are actually able to use less blades to handle more power. In the previous years, if you had a 800 horse RHS with a 268 and you had an 8-blade Sabre on that, that was a really, really good combination. If you're on a step, a sled, anything like that, you can now put a 7-blade Talon on that same setup, and you won't lose any performance, but you'll gain snap, you will gain whole shot, throttle response, less torque roll, and just a better 0 to like 400 if you're talking feet time. That's what we're focused on with this, is time, not actual overall top speed. But that's the target goal with this. We hope that you enjoyed this installation video. Thanks and have a great day.